the same we are going to practice again here. That is the Gibbs free energy only. So let's see the problem, what the problem is saying. Here you see the question. Calculate the, here they are saying, यहाँ से आवाज आ रहा है यार. Here they are saying, calculate the standards Gibbs free energy change from the free energy formation data for the following reactions. So one reaction has been given here. You can see benzene. This is the benzene is getting no react with oxygen. So it is giving 6 mole of CO2 and 3 mole of H2O. That we need to keep in mind. Okay, this is the reaction already given. Now, I told you Gibbs free energy for reaction. How we calculate Gibbs free energy for reaction? Free energy for reaction. If we talk about Gibbs free energy for reaction, so the formula is there, what? Delta G naught reaction Rxn is equal to, it is going, that is delta F for formation, delta F G naught product. Here we have to write that is product minus, it is will be, that is delta F G naught. Here is delta F G naught. It is going to be reactant. Okay, so that is how we calculate Gibbs free energy from the reactant. You know, in Gibbs free energy from product and Gibbs free energy from reactant. This is our formula, right? So what we are going to do, we are going to apply for these questions. Okay, so it is 6 C6H6 plus half 50 half, 15 by 2O2, 6H2O, 3H2O. So let's try to write this. Yeah, wait. Oh, it's not rotating at all. It's not visible. Datas are not visible. So here datas are not mentioned in this PDF. It's not showing anything.
Yes, sir.
Yeah, here it's got. So what we can do here, the same formula, you need to write the formula also. Okay, this formula you need to write. Got it? Whatever the formulas are there that you need to write here. This one. So Gibbs free energy for the reaction is what? It is going to delta G naught is equal to delta G naught product minus delta G naught reactant, right? So here you see, these are the datas are there. So how can you be able to apply this one? So we are going to apply this same. Okay, I have taken this from the book. So here you see the reaction was there C6H6 plus 15 by 2O2. If you are giving what, that is 6 molecule of CO2 plus 3 molecule of H2O. If you see, this reaction is completely binary. 6 to the 12, 3, 15. Here is 2 will be cancelled out 15. So if you are applying this one, delta G naught reaction, if you are writing here, so that is product. These two are going to be product, and these two are going to be reactant. So product means what?
Yes,
that is 6 into enthalpy of, gives free energy of formation of CO2. So delta F G naught CO2 we can write plus 3 into delta, okay, F G naught. Here will be the G naught. Okay, what will be there? Here is, this will be, we are going to write that is H2O. 3 into delta F G naught H2O minus what we have to write. See, is for the free molecule, this O2, this O2 in the universe, it exists in this form only, half O2. So this is means O2 form. O2 is the standard form. In the standard form, you need not to form. Like H2 is there, O2 is there, they are forming itself. So for them, it is going to be 0. Gives free energy for them, it will be 0. So firstly, let me write here delta, okay, F G naught, it will be C6H6 plus this will be what? Delta F G naught, it will be 15 by 2 delta F G naught O2. I told you for O2 it will be 0. That you need to keep in mind.
Yes,
Why O2 will be 0? Because it is standard state. Okay. Now you please
yes,
plug the value in this equation. You plug the value. How can you plug the value? Whatever the values are there. For they are saying delta Fg naught, this value they have given. For benzene, they have given this much. Carbon dioxide, they have given this much. And H2O, they have given this much. Okay. So we need to solve this one.
yes, sir.
So let me write that is delta G naught reaction RXN. So product, firstly we have to write product. So 6 into CO2. So 6 into
Yes,
CO2,
sir.
you can check the value here is minus 394.4. So this is going to be minus 394.4. Again, you need to see that is what are their oxygen. Oxygen, I told you that is in the standard state. This is oxygen is standard state. It will be 0, like that is H2O2, they exist in the environment in the same form. You need not to prepare them. So this is
Okay,
another,
sir.
there is minus, we are going to write reactant. Reactant is what there. Okay, so reactant, if you see the oh, little bit missed. Product, this is the product we have to write now. Firstly, product minus reactant. So product is 6 into CO2. CO2 we place rightly 394. And then water
Yes,
is
sir.
there. 3 into water value,
Yes,
how much is there? Minus 228.6. Then negative sign, it
yes,
will
sir.
come here. This is 0. So 1 into benzene. Benzene value is there
Yes, sir.
172.8 plus 15 by 2 into 0, because oxygen is standard state. In the standard state, the enthalpy of formation is 0. So let's see, enthalpy of formation or Gibbs free energy will be 0. So here let's try to calculate it out. Okay. So you can also try to calculate these values. I'm also trying to calculate. Do
Sir,
the,
your voice is breaking.
my voice is breaking. Oh, oh, wait. So here, is it audible now? Audible?
Yes, sir.
Okay, okay. So here you see, if you multiply this one, okay, if you multiply this one, so how much coming? You can also type simultaneously multiply 2,
Yes,
3,
sir.
6, 6, 4. This is there. This is minus. If you this
Yes, sir.
multiply, so you know this is the plus, this is minus. Plus into minus, it is going
Yes,
to be
minus.
685.8. Here is the minus. Okay. So minus it, this value 0. Here if you are multiplying, so minus into plus. So this is going to be minus only. So 172.8. This is going to come. Now, what we need to do, these all are the negative, and in the negative term, it is going to add. So how much is coming? So this is the minus 3,224.6. This is coming 6. These all value are kilojoule per mole. So this is also coming kilojoule per mole, right? Kilojoule per mole. This is
Yes,
the value, right? Now what we need to do, this they are saying that is this will be the spontaneous or not spontaneous. So before that I told you, okay, for the spontaneous case, what I told you, I could told you that is delta G naught. If it is there, how much? If it is there, 0. So this is equilibrium case. This is going to be equilibrium, right? If delta G naught is going to be positive, you know, so positive means non-spontaneous. It is not spontaneous, not spontaneous.
yes, sir.
If your delta G is negative, negative means it is going to be spontaneous. Okay, so that we need to keep in.
Yes,
This is the spontaneous. So this is our required answer. So delta G naught is negative. So this will be what? That is spontaneous. Will you be able to understand this one?
yes, sir.
Okay.
It is a bit confusing, but I can.
Little bit. We'll solve some more problem. It will be clear. I think it will be clear to you.
Wait, sir, I'm just noting it down.
Okay, okay. Done?
1 minute, sir. Yeah,
Okay.
done.
Okay. So can I erase this one?
Yes, sir.
Okay. Wait a moment. What I'm going to do, I'm just trying to make enlarge the size of this page, but it's not getting larger size.
Okay, sir.
Nothing is happening. Oh, okay, not that much. So okay, making clear. Okay, this one question is over. Let's try to see another question. This is the one more questions I've given. How can they ask in the NEET exam that you can try here? So if you see this one, so what is the question? Consider the reaction. One reaction has been given. Okay. So ammonia reacting
Sir.
with the oxygen, it is giving the nitric oxide, and this one, the 6 molecule of water. Delta G naught they have given. Delta G naught means it is reaction they are giving. So minus 1010.5 kilojoule per mole. This will be, that is NO formation they have given. Okay. And NH3 formation they have given. Okay. So NO, if
Yes.
delta, this one is there. Calculate delta Fg naught NO. If, see, we need to understand the question also. If delta Fg naught NH3 is this one, and delta Fg naught H2 is this one. So that already I told you formula. How can we are going to delta G naught reaction. Delta G naught reaction is going to be what? That is what can be. Here is delta G naught product. Delta G naught product minus delta G naught reactant. Delta G naught reactant. Okay. So delta G naught product, what will be there? 4 into NO. I can write delta F G naught NO. Then this one, then that is 6 into 6 into what will, that is F G naught H2O. Okay, H2O. So here is the, this, they are the product. NO and H2O are product. Then reactant we are going.
Yes, sir.
Delta, that is, it is 4 delta Fg naught formation of NH3, and then it will be, that is what will be there, 5. This is going to be 5 Fg naught O2 standard state. This is the standard state itself, it form. So its value will be 0. That you need to keep in mind. Okay, let's try to
Yes,
plug the
sir.
value. So 4 into delta Fg naught NO, how much is there? So NO they are asking. Keep in mind, they are calculate delta Fg naught NO. So they are asking. So I'm writing F, no, Fg naught delta, what they have written, delta Fg naught. You can write any side of the F, there is no problem at all. Okay, so delta Fg naught and NO they are asking. Here is what they are asking, H2O they have given. So it is going to be 6 molecule, and H2O how much is there, you can check. H2O is there, if you see here in the question, H2O is minus 237. H2O is minus. So 6 into minus 237. Okay. 237.2 this. Okay, minus 4 into NH3. So NH3, where is the NH3? You can see NH3 16.6. So minus 16.6. Okay, plus 5
Yes,
into, if you see, it can be 5 into O2. So 5 into O2 value is 0. That you keep in mind. Okay, let's see what we can do, because O2 I told you is standard state 0. Here delta G naught reaction they have given how much? This is the minus 1010.5. Okay, this
yes,
one.
sir.
Okay, let's try to calculate here. So minus 1010.5, and here is what is going to be, that is 4 into delta Fg naught NO plus. What is, if you are multiplying this one, you multiply and see the how much value you are getting here. So if I will multiply this one, it is coming, something coming 1423. This is coming plus into minus, it is going to be minus. You know, so here I am plugging the minus, minus 1423.2 plus minus into pi, minus if you are writing plus, it is 66.4. This is coming. Let us try to see the again minus 1010.5 is equal to 4 into delta f g naught n o minus. If you solve this out, if you solve this one, so how much is going to come here? See, if you, this is the minus, minus sign is larger, 66.6. So minus sign will take, so it is 1356.8. This is coming, right? Now you send this value to this side. If you are sending, this is going to be positive one. So here you, I am calculating here 4 into delta f g naught, right? If you are sending this side, so what is going to be there? Minus 1010.5, and this will go that side, so it will be the positive value. How much is coming? So 1356.8, right? If you solve this one, how much is coming? Plus into minus, so which one is the positive is larger value, so that is positive will come. And how much is coming here? It is coming 346.3. But here asking that is delta fg naught. Here you see calculate delta fg naught. So here is 4 into delta fg naught is there. So if you are writing that is delta fg naught, so this is going to be divide. So 4 will be going to divide. So how much value they are saying? 86.6 kilojoule per mole. This is our answer. This is our required answer. Can you understand this? Is it okay, Janab? Can you understand? Audible?
Hello, sir.
Audible?
Hello.
Yes, yes, yes.
Sir. Yeah, sir.
Okay. Will you be able to understand this?
Yeah, sir. I understood.
Okay. Can you please make a note of it, please? Completed?
No, sir. Just
Okay, okay, okay. Done.
Sir.
Completed. I think some network issue is there from my side, so that you are facing the problem. Done, Janab, done.
Sir, last time there.
Okay. A little bit network issue is there as today. Done. Done.
Done. I said na, sir, done.
No, I was not listening. Little bit network issue is there today here. It's a very slow
Okay,
network.
sir, yeah.
Okay, let's see. See, one more problem is there. Can we solve this problem? Okay. So if you see this problem, quite okay, good problem. Here you can have, they are saying calculate delta G naught, R for reaction for the following reaction using delta Fg naught values. Predict the reaction are spontaneous. They are asking the reaction is spontaneous or not. So if the value is coming negative, so that is reaction will be spontaneous. So this type of problem asked in the NEET or JEE exams that we need to see. So that is, if suppose I am doing that is one problem, let's try to do at least one problem. Okay, another you do by yourself. So let's see the first one. First one, what they are saying here, if you see, calcium is there reacting with Cl2, CaCl2 is giving. So how we can calculate? Delta G naught reaction is equal to, it is what? That is the delta Fg naught product. Okay, this is the product minus delta Fg naught. It is going to reactant. This is what now. So delta Fg naught product, how many are there product? If you're talking about product, so product means what? Delta Fg naught CaCl2. Okay, and next one is that is reactant delta Fg naught. It is Cl going to be, Cl, not Cl. This is the Ca. So first, this is going to be Ca. Another reactant is there. What? That is what delta Fg naught. What is there? This is the Cl2. So it is going to be Cl2. So these many are the there that we need to write. So delta Fg naught CaCl2, and second one is delta Fg naught Ca and Cl2, right? So let's try to write down the values here. How can we be able to put the value? So their multiplication are all are the only one. Here you can see one. Here is also one. Here also one. So we need not to multiply. Calcium is standard state. Calcium is, that is standard state. Standard state. Standard state means it form itself. It form itself. Itself, or or it exists in nature in this form. It exists in nature. It exists in nature. Okay, it exists in nature in that form, in this form only, in this form only. So delta Fg naught for calcium is 0. Okay, that you need to keep in mind. Okay, because we are not going to prepare the calcium itself is present, so this is there. Okay, Cl2 we prepare. So what are the value are there? Let's see. That is CaCl2 they have given this one, then HGO is given, NH3 is given, NO3 is given, H2 is given. Means Cl2 also exists in this form, so it is also will be 0. So if you are talking about this one, so CaCl2 value is given. So CaCl2 how much is there? Minus 748.1. Here will be what? Calcium will be 0, and then Cl2 it is again going to be the 0 only. So 0 plus 0, so that is 0. So here is delta Rg naught. It is coming what? Minus 748.1. So since it is negative, so if it is negative, so this is going to be spontaneous reaction. Spontaneous reaction. Spontaneous reaction as delta G naught is negative. Can you understand this? I'll share the solution, detailed solution of it. I am having. I will share this one, detailed solution
Yes,
also, but here you can see. Can you understand? Hello?
yes, sir. Yes. Okay, sir.
Hmm. Can you write this one?
Yes, sir.
Calculate for the second one. For the second one, Hg is standard form, so it will be 0. O2 is standard form, this is going to be 0. So will be the second one is the spontaneous or non-spontaneous? Just tell me. Second will be spontaneous or non-spontaneous? Done?
No, sir.
Okay. Question need not to write, Janav. You leave the space for questions. I will share the questions. You can write the only solution.
Sir, I was writing the questions also.
No. Question I will share. Question I will share to you. No problem.
Sir, okay.
Hmm.
Yeah, sir, done.
Okay, good. Second one, you tell me. Second one, you try to tell me. Second one. What will be this one? What will be this one? This will be spontaneous or non-spontaneous, or tell me that is delta G will come negative or delta G not will come positive. What will come? See, Hg is the natural state. Hg is from metal. It is found in this form. So its value is going to be 0 only. It is 0. Oxygen also found in the naturally this form. So it is also value will be 0. So what will be delta G naught value? Hmm? So delta G naught, if you are writing product, so product are Hg 0 and O2 is 0. You can write that delta G naught, this is going to be Hg plus delta G naught, that is 1 by 2 delta G naught O2 minus it is going to be that is delta G naught, it will be HGO, right? This one. So that is, this is 0 plus 0 minus delta G naught, this is negative. The HGO value they have given, how much they have given? This one. So minus 58.84. Now you see minus into minus plus. So that is delta G naught reaction is equal to plus, it is positive. How much coming? 58.84. So 58.84 means it is going to be what?
Sir.
Non-spontaneous. Non-spontaneous. Are you able to understand this one? Is it
Yes,
clear?
sir.
Okay.
Yes, sir.
Mhm. This chapter is supposed to be over, Janab. This chapter got over, right? So we'll solve some of the problem from your book. You also try to solve, and whichever problem you are not able to solve, just send me back. Okay. I will solve and I'll make the video and send you back. Right.
Okay.
Hmm. You write down, then I will share your book. Hmm. Done.
Sir, just
Okay.
done, sir.
Done. Thank you. So let's try to solve another one where we can go this one. Let's try to share your, is there anything? One second, I'm sharing the book. Yeah, it's gets
Done.
saved. Yeah. Yeah, this is the book which you have given, but it's quite very small size.
So I sent
Hmm.
you Akash material. Means like it's from Akash material.
Okay, no problem. We'll solve that one also. This is, I don't know which material is this. Okay,
Sir,
chemical.
I cannot see the screen. It's stuck.
Okay, it will be visible. Wait. Let me increase the font size again. Huh. Is it visible little bit? Is it visible?
No, sir.
That is how you share na, the same one. Screen is shared na. Screen is shared na. Little bit. It may be blur, but it is visible. Yes, yeah, no.
Sir, ACA plus Cl2. That.
Acha, that is being seen to you. Wait.
Yes, sir.
No, wait. I shared this one.
Sir, you
Now,
didn't share your screen.
now,
Yes, sir. Now.
now this one. I think this is the question number 2, which you shared earlier to me. Okay, so let's try to solve some of the problem. This is question number 2. One, I think you shared in another page. This is question number 2. What they are saying here, an isolated system is that in which isolated system they are asking. So three
Yes,
type of
sir.
system I told you. One is the open, then another was the
Yes, sir.
closed, and third was the isolated. Isolated. If open system is there, open how we cook the food, how we cook the
Yes, sir.
vegetable. So what is happening? Matter also, water get scattered, energy also getting
Yes, sir.
extended. So in the open system, what is happening? That is matter plus energy. What you can write, that is a heat also energy. These two are getting exchanged. Yes or no? This is going to be exchanged.
Yes, sir.
A close is there, close. So matter is not going to exchange. If it is closed, suppose cooker is there, you can't exchange the matter. But what is there?
Yes, sir.
Heat can be cooled. Heat. So matter. If you are talking about matter, so matter is not going to exchange. But heat, if you are talking heat or energy, going to be exchanged. Okay. Like hot metal pot is there, they become cool. Okay, isolated system. Isolated system, I told you, this is the thermos flask. Thermos. Okay, thermos flask. Thermos flask means what? That is neither the heat is releasing, getting out, or not. That is the another thing is there, matter is out. Okay, until or unless
Yes,
because
sir.
closed. So here is the heat and matter. If you are talking about heat and matter,
Yes,
do
sir.
not exchange. Do not exchange. So now we need to find out which is the option is correct. There is no exchange of energy with the surrounding. They are talking about no exchange of energy. The first option, only energy. Second option, there is
Yes, sir.
exchange of mass and energy. Exchange of. But what we are saying, that is do not exchange. Getting. Third point. Third point, what they are
Yes, sir.
saying, there is no exchange of mass and energy with surrounding. So correct option is option number this one. There is no exchange of, there is no exchange of mass and energy with surrounding. Are you be able to understand this one, third one?
Yes, sir.
So our required option is option number will be third. Yes. Last option not will be there. There is exchange of mass with the surrounding. No, mass is not going to exchange with the surrounding in case of the isolated system. Yes.
Yes, sir.
Okay. So this is the option number third. You need not to write this one. I'm explaining. Okay. So let it be like that. Okay. Next one, question number third. What they are saying? A well-stopped thermos flask. They are saying thermos flask. They have taken thermos flask. Thermos flask means what type of system will be? Isolated system. Okay. If you are talking about well-stopped thermos flask means what kind of system is there? Thermos flask is example of isolated system. Yes or no? Isolated system. Yes or no?
Yes, sir.
Contain some ice cube. This is example of, so here is the iso, this is suppose this is the isolated system. Isolated system is this is the closed one. Yes or no? This is going to be closed one. Yes. And second one, what is there here? You see. Okay. This is this one. You see this one. Here is the ice cube are there. So since it is the, they are saying thermos, this they are saying thermos flask. So thermos flask is there. Thermos flask means it is isolated. So isolated means that is the ice cube will be the same. Okay, it is not going to melt. Ice cube is not going to melt. So they are saying what kind of system is a thermos flask is the isolated system. So they see they are asking closed system, no. Open system, no. Isolated system, yes. Thermos flask is example of isolated. Non-thermodynamic, no. So correct option is again going to be 3. Yes or no? Can you
Yes,
understand
sir.
this? Okay,
Yes.
now let us move the question number 4. So you see the question number 4, what the question they are saying? They are saying question number, a system which can exchange energy with the surrounding, but no matter is called. A system which exchange energy. Energy is being exchanged, but matter is not exchanged. Janab, can you please tell me the answer? It is open, close, isolated. Which can be? They
Yes,
are
sir.
saying, they are saying energy changing, but matter is not changing. Which can be answer?
Sir,
Hmm. Matter
not
changing.
matter.
See.
Open.
No, see. Think on it. Matter not changing. Matter not changing means you cannot remove the matter, but energy is changing. Energy is what? Energy is being exchanged. So which can be answer? Tell me.
Okay.
Hmm. So it is the closed system. Why? If it is the closed system, suppose metal container is there. So closed metal container is there, na? So energy, matter can't be. Closed means what? You can't remove the matter. Yes or no? It is closed.
Yes, sir.
So from the closed, you can't remove the matter, but it is metal container. It is metal. So metal is there. Matter can be hot or cold, na? That can be the cooling system is there. Matter is conductor of electricity or heat. So what will be there? Closed metal container is there now. So what will be
Yes,
there?
sir.
Heat will be transferred or energy can be exchanged. Okay, cold will become hot, no, hot will become cool. So energy is exchanging, but matter is not exchanging. So this system is what type of system? What type of system?
Sir, closed.
Closed system. Okay, so this is the our answer will be option number 3. Can you understand now this one?
Yes, sir.
Okay, very good. Let's see the next one. Okay, question number 5. You can open the book also if you are having the book. You have sent, this is the PDF sent by you. Mhm. So fifth number, an intensive property of thermodynamics means property which depends on, see, I told you property, two types I told you, property. So one property I told you intensive, this is the intensive, and second one extensive. So extensive means mass and size dependent. Yes, mass and size dependent. Intensive, not depend on mass and size, not depends on mass and size, not depends on mass and size. So which can be our answer? You check the answer and tell me. You check the answer and tell me.
With an intensive property of thermodynamics, mass, a property which depends both amount as well as nature of the substance.
So they are saying, see, first one is amount of the ice, no. Amount of the
No,
substance, no. And the nature of
no,
substance,
yes,
nature can be both on amount as well as nature. This
both
is
are
the
the
extensive. Neither on the
neither
amount
on the amount.
nor the nature. Okay. The intensive
Yes,
properties, if you talk about na amount, it is option number D will be there. Option number 4.
yes, sir.
It is not change depending on the amount or the nature also, because how the B we are deleting on the nature of the substance only. This is not the correct. Okay,
Yes, sir.
they are not depending on amount also. Intensive properties not depend on mass. Mass means amount. Will you be able to understand this fourth one?
Yes, sir.
Okay, this is the now next question. You see the next question. What is the question number 6? The intensive, they are saying the intensive property among the following given quantity are intensive. They are asking intensive. Okay, intensive means which is not weight is depend on mass. Suppose my mass is dead, so weight will be high. So it is the weight is the extensive. It is mass dependent. Entropy delta S greater the delta S is equal to what? Q by T. Okay, Q by T.
Yes, sir.
Up Q by T means Q we can write here is Q heat capacity we can write in this one now. So Cp is equal to Qp upon dt delta T. So Qp if you are writing Cp dt, okay, Cp dt. So it is coming that is delta S is equal to Cp delta T upon T. It means that is C is there now. C is what? That is molar heat capacity. Molar heat capacity, okay, or his specific heat capacity means it is depending on the mass. So entropy is also extensive. Okay, volume greater the mass greater the volume. Suppose I am having the two book, one book is very large size, so mass is large, so it is the extensive. So which can be the answer? The answer will be density. How high? How density? Suppose I am having the metal rod, this much size metal rod. This is the iron. Okay, this is the iron.
Yes, sir.
So if the iron is there, Fe is there, what about the density is there upside here density or the downside? So if you cut, the density will be remain the same here and here. So that is what, even you are cutting, the density is same now. So density is not depending on mass. So density is what type of property? Intensive. Can you understand this one? Yes, yeah,
Yes,
no.
sir.
So this is the answer. Getting.
Yes.
Okay, next one, question number 7. Which is an extensive properties of the system? Okay, so tell me the answer. Which can be extensive? Volume, viscosity, refractive index, temperature. You can check from this question answer option. You can study this one 6 numbers, so 7 easily you can answer.
Yes, sir.
Hmm.
So, sir, it's second.
No, you read. See, weight is there, density is there, entropy is there, volume is there. So they are asking is
Mm,
extensive, na? So which can
mm.
be? So weight, entropy, volume are extensive property. So volume will be extensive. Volume. More volume means what? Volume means proportional to mass. Volume proportional to amount. Yes or no?
Yes, sir.
More the amount, more will be volume. So option will be what? Option number 1.
Yes, sir.
Can you understand this or it is getting tough?
Oh, sir, it's getting tough.
Okay. Can we do tomorrow then?
Yes, sir, please.
Okay, okay. So we'll be studying it the in the next class, or we can start the that is periodic property you told me, na?
Yes, sir.
Okay. So you also read
Sir,
out this
I'll send you if you want.
periodic property. Na, please send me. Na, please send me.
Okay, sir, I'll send you.
Okay, 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 okay. Bye, bye. Take care.
Bye, sir. Thank you.
Hmm.